Something like that. Something like that. All right. So we did these yesterday again. Anytime we're finding the inverse, we want to change that f of x to a y, and then we're going to switch our x and our y. All right. And then Missy, I heard you say once we do that, what do we want to do with our steps?
Put a 1 underneath the x and then cross multiply.
Yep. We're going to cross multiply, put a 1 underneath there. We can cross multiply. So that would give us x times the quantity of y plus 1. We have our equal sign, and when we cross multiply this way, we get 2y minus 3. All right, so then after that, again, we're trying to get all the y's on one side, the numbers on the other side. So we are going to distribute our x through so that we can essentially do that. So that would give us xy plus x, and then we get 2y minus 3. All right, so our goal again is to try to get y by itself. So to get y by itself, we need all the y's on one side. So there's a 2y on the right. I'm going to subtract the 2y to move it over to the left. There's an x here that I'm going to move to the other side, so I'll subtract x. All right, so on the left, these x's go away, the y's go away on the right side, and I'm left with xy minus 2y. That's equal to negative 3 minus x. So what can we do with that left side now? Because there's y's in both those terms.
Take out a GCF of y.
Right, we're going to pull out that GCF of y. And remember, pulling out GCF is essentially the same as putting that y in front and then dividing each of these by y. So we'd be left with x minus 2 on the inside. And I'm just going to put the x first, negative x minus 3. All right, so the last thing we have to do to get the y by itself is then do our division. Right now we're multiplying, so we can divide both sides by x minus 2. Okay, so those x minus 2's cancel. The y is essentially by itself now. So therefore, we can use our inverse notation. So I'm making that y f inverse of x. On the right side, we have negative x minus 3 all over x minus 2. And we can just say x cannot equal positive 2. Because 2 minus 2 is 0. Did anyone pull out a GCF of negative 1 on the top? You can also do that. Okay? So if you wrote it as negative x plus 3 over x minus 2, that's acceptable also. There we go. All right, questions on that at all? So that's going over what we did yesterday. The other part of what we did at the end of the period was the one-to-one function. So if you go back to where we were at yesterday, you might want to just make sure you have proper notes for that, for the one-to-one function. Okay, so that was kind of the end of the period yesterday. I know we were kind of running out of time. But just remember, if something passes the horizontal line test, then it's one-to-one. So passing the horizontal line test just means the horizontal line crosses at one spot. And another way of saying it is no two ordered pairs have the same y value. Okay, so if it's one-to-one, that also means that the inverse would be a function. Okay, so as we went, and again, we kind of went over these a little fast yesterday at the end of the period, but this graph, this absolute value graph, passes the horizontal line test, or sorry, we put the horizontal line in there, and you see it crosses at two spots. So that's not one-to-one, and that means the inverse would not be a function. Okay, that's what that means. If it is one-to-one, then the inverse is a function. So the other two, B and C, the horizontal line crosses at only one spot. So those are one-to-one, which means our inverse is a function. Did we do D and E yesterday or not, or did we do the graphs yesterday? Forget where we left off. All right, so let's look at the graphs also then. Sorry, we'll look at D and E. So you can go ahead and write these down. So again, the question is, are these one-to-one? So if we go back to our definition, our definition of one-to-one was it can pass the horizontal line test, or we said no two ordered pairs have the same y value. So if you have the same y twice, then it's not one-to-one. So if we look here, these are different y values for each of those. So that means this one would be one-to-one. And again, if it's one-to-one, that means our inverse is a function. What about E? What do we think about that? What do we know? It's not one-to-one. We have two 5s in those y values, right? There's a y of 5 here, a y of 5 here. So that's not one-to-one. And again, that means our inverse is not a function. All right, so those last problems on the homework, 29 to 34, that was talking about whether they were one-to-one or not. So I'll put those up on the board in a moment. All right, so 29 to 34, we're right here. And the question was asking, are they represent, it says which graphs represent functions that have inverses? Inverse functions. So a way of saying this is, are they one-to-one? And if so, do those inverses have functions? So take a moment, talk with your group, and just say which ones are one-to-one, which ones have inverses that are functions. All right, which one do we think's? Give me one. Shai, what do you think? Which one of them that is a function?
That is a function? 30.
30. 30 would be, it passes the horizontal line test. So yep, that's one-to-one, and the inverse is a function. Yep. All right. Tyler, go ahead.
31.
31 is what? Is or is not?
Is.
So if we that's crossing more than one, so that's not going to be.
29 is not a function.
29 is not also, so we'll say not. We said this one is a function. Alright. Did you say? Alright, I was gonna
You did ask. I saw it.
Joey and I have a. Yeah. Alright, what else we got? Last, can you give me one of them? I don't care. You can.
32 is not a function.
Alright, 32 is not. 32 is a little tricky because at first it looks like it is, but this part right here, it's be straight horizontal line, so that's not. Good job. Alright, we got two left.
33 is a function.
Yeah, and 34. Both of them are. Yep, both of them are going to pass that horizontal line test no matter where you draw it. So these would be have inverses that are functions. All right. So that kind of totally closes what we did yesterday. You good with that? All right. The last part of this section is dealing with kind of looking at inverses that would not be functions and how can we make them be functions. So 23 was on the homework last night as well. So a lot of people, as I was checking in class yesterday, did a good job. We just have to finish this a little bit. So we switched our x and y, and then how did we undo the square root?
By squaring it.
Just square it. Okay, so that would give us f inverse of x, because the y would now be by itself, we're changing to f inverse, equals x squared. That's what most people got. And I kind of expected that, okay? From where we're at, that's a good answer. However, today we're going to take that a little further. So what does our square root look like? That's one of our parent graphs. And I know you know, we talked about that yesterday.
Yeah, it's just it's weird to explain out loud, but you know what I mean, it's just a one line.
Yeah, it's starting here and then it goes in one direction. The Harry Styles one, right?
Yes.
Alright. Now, what does the parabola look like though? That's a U, right? So, we talked about this a little bit. On our tables, we're just switching our x and y's. So if I switch my x and y's on the original one, am I going to get a full parabola? No. I'm only going to get which half of my parabola? The left or the right? I'm only going to get the right. So this part really is not there. So what we have to do is we're going to add a little restriction, kind of like when we did piecewise functions. We're going to say where x is greater than or equal to 0. Okay? By doing that, we get rid of the left half and we just keep the right half. Okay? So I wasn't quite expecting you to be there in the homework last night, that's why we went over it, but that's what we're going to be working on more today. Like how can we get rid of half of it so that these are going to be functions. Okay? Alright, so that takes us to where we're at right now. And this is kind of the newer part. So in your notes you can write, we'll find the inverse of this function. And notice we have one of those statements back there now. So it says f of x equals x squared plus 1. And we have that little statement at the end. It says x is greater than or equal to 0. Then we're also going to talk about the domain and range of these. So here we have x squared plus 1 graph, because remember this would be a parabola up 1 unit. So you can just make a quick sketch and move it up 1 unit. But because we have this little statement at the end here, if x is greater than or equal to 0, that's saying we only start at 0 and have everything that's larger than 0. So we'd be going to the right. So would we have this left side? No. So we can actually kind of scribble out this left side so that we don't have it there. Because if we had that full parabola, would the inverse be a function? No. But now that I got rid of this half, is the inverse going to pass that horizontal line test? Yeah. Okay. And that's what we wanted. We want that inverse to be a function, so we had to get rid of half of it. Alright, so now as we go ahead and try to find the inverse, again, first thing I'm going to do, change that f of x to a y, we switch our x and y. So what's the first thing we'd have to do to get the y by itself? Cody, what do you think? What's the first thing we have to do here? Get the y by itself.
Subtract the 1.
Yeah, subtracting the 1. And then we're going to undo a square by taking the square root. So we're going to take the square root of both sides. Now normally we take the plus or minus the square root because I say that. But because we only have half of it, we don't need the plus or minus. So we're just going to use the positive square root because if we think about a parabola, we only have the positive x values of that right now. Okay, we don't have the negatives. So we're only going to use the positive square root in this case. And then we are by itself here. So the square root, just the positive square root of x minus 1 equals the inverse. And so as we kind of were just talking about, this would be the square root moved 1 unit to the right. Our scale's going by 0.5s here. So it would be something like this. Okay? And notice there is a line of symmetry along y equals x also, as it should be. But we don't have this part because we don't have the bottom part because we don't have that half. All right, take a moment and try doing the domain and range for the the original one, and also the inverse.
What?
So again, when we're doing the domain of f of x, we're just doing what's not scribbled out. So just this half, the right half. And then you're finding the domain and range for the red one also. All right, so first thing I would say, when you see these restricted values, first thing I would do is make a quick sketch. Doesn't have to be nice, doesn't have to be pretty, just a quick sketch. I know this is going to be a parabola because it's squared and it's going to be shifted which directions?
Left, right two.
Right 2 and up 1. Here's 2, here's 1, and the negative in front is going to move it which way there? Upside down. So it's going to look something like this. Now, because we have that little statement at the end, x is less than or equal to 2, which half would we actually have? The left half or the right half now? We have the left. We want x to be less than 2. So this part is less than 2. So we'd actually be getting rid of the right half in this case. All right. So as we go and find our inverse, again, changing the f of x to a y, switching our x and y. And as we try and get the y by itself, we'll be doing PEMDAS backwards. So opposite of the plus 1 is subtraction 1. So that's the first thing I'm going to get rid of, that addition, subtraction. This is what got a lot of people in the last period, or period before. This negative is really, remember, negative 1 times. Okay, so that's multiplication by negative 1 out front. So how do you undo multiplication by negative 1? You want to divide, right? So I would divide both sides by negative 1. So I'm going to just go ahead and divide by negative 1. X divided by negative 1 is negative x. Negative 1 divided by negative 1 is positive 1. And then I'd be left with y minus 2 quantity squared. And then to undo our square, we would be taking the square root of both sides. So this right side would just be y minus 2, because that's going to undo this. The square and the square root cancel. Because we have this left side of our parabola now, are those the positive x values or the negative x values of that parabola? Why is it negative? If you think about where, if this started at 0, 0, the left half is those negative sides. So because we have the negative side, the negative values, we need to use just the negative square root. It's not going to be the plus or minus, it's just the negative. So I'd have the negative square root of negative x plus 1. And then to get the y totally by itself, we have to add 2. So the y would be by itself now, so that's going to be changed to f inverse of x. And then we're left with the negative square root of negative x plus 1 and then plus 2 on the outside. So I'm going to have you guys write something down because it helps you remember if you're going to have the positive square root or the negative square root. Okay, so the left half of the parabola, if you have the left half of the parabola, you're going to use the negative square root. You'd have the left half if it had a less than or equal to symbol. Okay, so the left half means you'd have a less than or equal to. That's what we had before on that previous slide, previous problem. If you have the right half of the parabola, then it's just the positive square root. And the left half of the parabola means you'd have a greater than or equal to symbol with that number.
Can it be greater than less than?
It could be. It could be. But then it'd be like an open dot at the vertex, which we're not really going to have because we can have the vertex. The vertex doesn't affect the horizontal line test. So make sure you have that written down. And then once you have that, you can start working on 41 to 44. I want you to try at least 41 and show me 41 before you leave. And I'll put it up in a moment.